In about 1,000 years, we humans will look very different. But why? And what does science have to say about how exactly we'll change? We all know that over the last several million years, humans have changed a lot. From our earliest ancestors who walked upright but still had large brains, to Homo erectus, who was starting to look more like us, to Neanderthals, who were fully modern humans but had some distinct differences. Humans have evolved alongside with many other species of humans. So it's likely that in another million years we may look vastly different from now. According to some scientists, the average human lifespan could reach 150 years old, while others think people will be able to live forever. According to these theories, the reason we age is due to cells that stop dividing. So if we can find a way to make these cells divide again, then we could potentially live forever, or at least much longer. Scientists are already close to making this a reality. Researchers at Harvard recently discovered a way to reverse the aging process by 5 years for $1.5 million. Granted, this isn't cheap, but this is only the first step. As technology advances, it'll become cheaper. In fact, scientists hope to one day be able to provide anti-aging treatments as common as eye exams are today. As people start living longer, their bodies may start changing. For example, with longer lifespans, there would be less need for the gene that causes menopause in women. Menopause happens because it is an efficient way for the body to get rid of the unused X chromosome. See, females have 2 X chromosomes while males have 1 X and 1 Y when an egg is fertilized by a sperm. So the resulting embryo will either receive the mother's X chromosome or father's X chromosome. If the embryo receives the father's X chromosome, it will develop into a male. If it receives the mother's X chromosome, it will become a female. After a woman goes through menopause, her ovaries lose the ability to produce eggs. And since those eggs no longer have a use, the body gets rid of the second X chromosome. But if humans live longer than 80 years, women would still have a use for that second X chromosome. So natural selection would probably act against the gene that causes menopause, meaning women could theoretically go through many more cycles of ovulation and menstruation, even up until the ripe age of 100 or more. But humans might not just be living longer, they might also be living larger. According to the Bergman's rule, animals that live in colder environments tend to be larger than their counterparts in warmer climates. As evidence for this, we need only look to the polar bear, which is much larger than its brown bear cousins. And humans follow this trend. People that live in colder areas like Northern Europe and Northern Asia tend to be taller and heavier than those that live in warmer areas like Southern Europe and Southern Asia. Studies have shown that people born in colder climates have a lower body mass index when compared to those born in warmer climates. And studies of ancient DNA have shown that genes linked to growth and height and weight became active only after our ancestors migrated out of Africa and into Europe, where the climate was colder. In fact, the average adult male in Europe today is 1.75 meters tall, which is almost 13 centimeters taller than the average adult male in Africa. So if global temperatures continue to rise, we may see a decrease in the average height and weight of the human population. This would also affect our extremities. People living in colder climates tend to have shorter limbs, hands and feet, than people in warmer climates. This is because shorter limbs reduce the surface area of the body, helping the body conserve heat. The average Inuit has arms that are 6 centimeters shorter than the average European. So as Earth gets warmer, humans might end up having longer limbs. But there are some scientists who believe the exact opposite will happen. According to Dr. David A., we might actually see a reverse trend where people in colder areas end up becoming even taller than they are today. Doctor believes that being tall is advantageous in cold climates because taller people are better at gathering food. Since food is scarce in the Arctic, natural selection will act for increased height in these populations. He points to the Inuits as an example. Even though they have shorter arms than other humans, their legs are proportionally longer than other humans. This is because the Inuit live in a climate that is too cold to bend down and pick things up, so they need long legs to kick snow around and move stuff with their feet. Meanwhile, they do and need such long arms because they can carry objects close to their bodies where it's warm enough to grab onto them. So maybe it's not global warming that will make humans shorter, but rather the Inuit that will make all humans look like them. But it's not just our height and weight that might be affected by climate change. Our skin color might change as well. For the last few million years, humans have gone from having dark skin to having light skin. At first, our ancestors in Africa had dark skin that protected them from the sun's harmful UV rays. However, once they moved to Europe, they needed more sunlight in order to make vitamin D, so lighter skin that absorbed more UV rays became advantageous. But as the Earth gets warmer, we might see another shift in skin color. Lighter skin allows for better cooling, since melanin, the pigment that gives skin its color, also acts as a sunscreen. People with darker skin have an advantage in hot climates because their bodies are better protected from the sun. So as the Earth gets warmer, we might see people evolving to have darker skin yet again. It's not just our bodies that might change, but also our brains. Today, human brains are 3 times larger than the brains of our ancestors, allowing us to do complex things like plan for the future, be creative, and problem solve. But brain size isn't everything. Some animals have larger brains than humans, but we definitely aren't the smartest species on the planet. There's also brain efficiency to consider. Using advanced neuroimaging techniques, researchers from the University of Pennsylvania were able to estimate the efficiency of various human ancestors. They found that the most efficient brain belonged to Homo habilis, a species that lived between 2.4 and 1.6 million years ago. Their brains were smaller than ours, but used energy much more efficiently. Between then and the emergence of Homo sapiens 300,000 years ago, brain size and efficiency both increased. But after that, brain size stopped increasing. Efficiency decreased. Modern humans have brains that are the same size as our ancestors from 5,000 years ago, but we use only about 20% of our brain's capacity. So it's possible that in another 1,000 years, we might see an increase in brain efficiency. If this happens, it could allow humans to be more creative, have deeper thoughts, and even develop new abilities that we can't even imagine yet. It could also lead to humans working together more efficiently to accomplish more than any other species on Earth. Or it could lead to humans evolving telekinesis. I don't know, I'm just spitballing here. And lastly, our sexual dimorphism might disappear. Sexual dimorphism refers to the physical differences between males and females of the same species. It's pretty obvious in humans. Males tend to be taller and more muscular than females, but this wasn't always the case. About 1.8 million years ago, the hominin species Homo ergaster appeared in Africa. This species was sexually dimorphic, but over time, sexual dimorphism decreased. In the Homo genus, our ancestors were pretty small and slender. Then, during the emergence of Homo erectus, sexual dimorphism increased. Males were larger than females by a greater degree. But beginning with Homo sapiens, sexual dimorphism started to decrease again. Men and women started looking more alike. Today, men and women look more similar than they did thousands of years ago, and it looks like this trend won't stop. Sexual dimorphism tends to increase when there are predators around, but since humans don't really have any predators, this trend will probably continue. And in 1,000 years, men and women might look nearly identical, at least physically. So what will humans look like in 1,000 years? Well, we're not sure. We hope they'll be taller, thinner, smarter, live longer, and have darker skin. But realistically, we could be shorter, fatter, dumber, have shorter lifespans and lighter skin. Basically, anything could happen. Ow. To learn what a world ruled by AI would look like in 1,000 years, check out this video or click the link in the description below. As always, this has been your host. Don't forget to keep on thinking.